Hi, let's see what is meant by object-oriented programming. We have the major advantages of object-oriented programming is like we can be able to manage the code very easily. Take, for example, we have a number of lines in a code in the sense when we write it with object-oriented programming, like with class, object. So if we have written with all these types of things, managing the code will be very easier. So that's why we are using it, and we have like overall understanding of the software can be increased. So take for example, we were actually separately writing a function, and take for example, I'm creating a calculator type of operation. So over here what I'm going to do is, so within this calculator I have addition operation in a separate function, subtraction, multiplication, division, so all those in a separate function, so such that we can be able to understand the software and its operation in an easier manner. And the second case is, so with the help of object oriented, so we can be able to maintain the use of encapsulation. So we will see what is meant by encapsulation. So which is nothing but the wrapping of datas and methods together is generally known as encapsulation. So that we can be able to easily achieve, and one can easily change the underlying representation by keeping the method same. So we can be able to keep the method same and we can be able to achieve it. And we have like object oriented programming can be able to write big type of software. Take for example a separate classes. As we have different types of classes, we can be able to integrate it very easily. So likewise, so all these types of things can be made very easier with the help of object oriented programming. This is one of the case. And take for example, let's see what is the major features of object-oriented programming. So over here, the majority of the features that we will be saying is one is encapsulation, polymorphism, and an inheritance. So like wrapping of data and methods together is generally encapsulation. Let's see what is meant by polymorphism and inheritance in the future things. Okay, let's see what is meant by encapsulation. Encapsulation is generally referred to as like data hiding and binding of data and methods together. So this is generally known as encapsulation. So take for example, what is meant by data hiding in the sense. So in take for example, any of the programming languages, so we can be able to restrict the members to the object. So in this case, take for example, I can be able to write the variable as private, and that's how I can be able to like declare the value. So this is what is known as data hiding. We are going to hide the data, and what we are going to do is we are going to bundle. So bundle in this case, in the sense we are wrapping in the same class. So that's what we are mentioning here as bundle, bundling of data and methods together. So that is known as encapsulation. Datas and methods that operate on the data as can be bind together. So we can see it in this pictorial representation itself. So we can be able to bind the datas and its data methods and its data members together. Encapsulated is known as encapsulation. So this is what is the we will be calling generally as encapsulation. Let's see then what is meant by polymorphism. So polymorphism, how it can be able to get supported in C or C++. So polymorphism is generally like we can be able to make some code operations that behave differently. So we will be having different types of polymorphism. So one is like compile time polymorphism and other is runtime type of polymorphism. In compile time polymorphism, what we will be doing is, so it means like, so take for example, whenever we were about to run the code, na, so in that time the polymorphism is generally occurring. So that's what is compile time polymorphism. So take for example, I have a method. So star, okay, I'm going to create a function within which I'm going to create two arguments. Let's have return type as void over here. So in this case, I'm having a separate function over here. This is function one. So similarly, I'm creating one more function which consisting of the same argument star, but we are using two arguments here. Now I'm going to create only one argument. So likewise, if the structure of the created function can be different, so that's what is known as compile time polymorphism. Even we can be able to have, here we have void, right? So we can also change it to int and then create a separate function. So the return type can also be varied in a compile time type of polymorphism. So clear? So this is how we will be generally creating compile time type of polymorphism. And then, so let's see this. Like compile time polymorphism means compiler knows which function should be called when a polymorphism is made. So which function we will be generally calling. Take for example, in this case, I'm going to use like star. So what is meant by runtime polymorphism is runtime polymorphism is supported by virtual functions. So like here we have seen like the function can have a different some sort of difference in both is known as compile time polymorphism. But in runtime, we will be using it in different classes. So that's what we will be generally calling it as a runtime polymorphism. The same function with at override. So somebody will be writing like that. Now, so through which we can be able to achieve this runtime type of polymorphism. Uh, yeah. Let's see what is meant by inheritance and what are all the purpose of having inheritance. So generally an inheritance is like we will be having a base class. Okay, we will be having a child class. The connection, so we are going to get all the properties from the base class to its derived class is known as inheritance. So the base class we will be otherwise calling like parent class or super class. So we will be calling it as like super class. Whereas in the derived class, we will be calling it as a subclass, or else we will be calling it as like a child class. So these are all the different types of different classes that we will be using. So from the base class, we will be getting all the properties, functions, methods to its child class. To its derived class is known as inheritance. So inheriting the properties from the base class is inheritance. What is the major use of having this inheritance? In the sense we can be able to reuse the code again. So take for example, we have written a code over in the base class. I'm going to get all the properties just reusing this function that I have created into a different class, so such that I don't need to write the same class again, right? So I can be able to reduce this. So code reusability can be totally increased with the help of inheritance. And we have different types of inheritance as well. So let's see, like we have single inheritance. So in single, in the sense we have one parent class and a one child class. So this is known as single inheritance. We have multiple inheritance. So multiple in the sense, take for example, we have two parent classes and we have only one child class. So which actually gets the child class is trying to get the properties from both its parent classes, which has the same method. So what will be the issue over here? We know that a Java virtual machine can't be able to compile which class should it has to run the program. So this is why, this is the only reason why Java doesn't support multiple inheritance. And we have like multi-level inheritance. So it is very simple. Take for example, we have a class A and class B and class C. We have three different classes which are interconnected with one another. Like class C derives the properties from class B and class B derives the property from class A. So this is multi-level type of inheritance. And we will be also having hierarchical type of inheritance. So hierarchical in the sense, we will be seeing the hierarchy, right? One parent which has two different child having getting the property from the parent class is known as hierarchical inheritance. So like class A, take for example, I have class A, class B, and class C. Class B and C are getting the function or reusing the function from class A is known as hierarchical inheritance. And the fifth type we will be having is hybrid inheritance. Hybrid in the sense, we will be having mixture of both multiple and hierarchical is hybrid. So these two will be combined together is known as hierarchical. So likewise, so we will be having a class A. Here we will be using hierarchical, and within we will be here we will be using multiple inheritance. So see here, it is multiple now. So multiple inheritance is over here, right? So mixture of both hierarchical and hybrid. Hybrid is like a mixture of both hierarchical and multiple inheritances, hybrid type of model. So these are all the five different types of inheritance we have. Let's see what is meant by abstraction. So abstraction is like the first thing that we will be confronted and while writing program. So take for example, it's like we will be hiding only giving the abstract view, hiding all the functionalities and showing only its overall view is known as abstraction. So in some of the cases, take for example, I'm just going to create a calculator type of operation. In the sense, I'm going to create abstract add, abstract subtract, abstract word multiplication, abstract word division. And in a separate class, I'm going to create all the separate function, like what is the addition operation separately, what is the multiplication operation. So separately, I'm going to create for each, so such that all the operations so can be made abstracted. Abstracted is nothing but hiding, we will be hiding all the functionality and only showing the implementation details is known as abstraction. Okay, so abstraction is generally of two different types. So we can able to achieve this abstraction we can be able to achieve with two different types. One is we will be using interface. So with interface also we can be able to achieve abstraction. With abstract we can be able to achieve. So the majority between what is meant by abstraction and interfaces, through abstract keyword we can be able to achieve partial abstraction. So partial in the sense, only like 50% can be abstracted, something can be implemented here. So likewise, abstraction can be done, partial type of abstraction can be done. Whereas in interface, we will be using implements keyword, and one more thing what we will be doing is it will be generally achieving 100% abstraction. So that's the major difference between abstraction and interface, so through abstraction we can be able to achieve only partial abstraction, and through interface we can be able to achieve 100% abstraction can be achieved. Okay, let's take what is meant by object-oriented programming system. So, object-oriented programming is generally like a programming technique. Which we will be using like we will be having different types like class, object, data abstraction, inheritance, polymorphism, method overloading, method overriding. So these are all some of the object-oriented programming system. So the state and the behavior of the object are represented. Like with the help of object oriented programming. The object oriented programming now, so programs are organized around objects and data rather than actions or logic. So we will be implementing with. Let's take what are all the advantages of using object oriented programming concepts. So take for an example, so let's see like why we were about to use this object oriented programming. First thing is simplicity. So for it, simplicity is the major reason why we were about to use it. Take for example, we can be able to separately create a class such that it won't create any complications within the main class. So if it is inside the main class, something might get confused. So likewise, if we are creating in a separate function, method overloading is done, inheritance of which code reusability can be done. So everything makes our code very simple. So this is one of the reason why we are using it. And we have modularity. What is meant by modularity is each and every objects that form a separate entity whose internal workings are decoupled from the parts of system is known as modularity. Generally, take for example, we can be able to separate it into modules as modularity. Modifiability. Okay, so like we can be able to modify the code. If any of the changes has to be done, we can be able to make modifications. So we can able to achieve loose coupling. So all these types of things can be achieved with the help of object-oriented programming concepts. Okay, let's see what is meant by extensibility then. Extensibility is like we can be able to add new features or response, like any features can be easily extended, it can be easily modified, we can be able to separate it into different modules, we can be able to achieve simplicity, we can be able to achieve the code, we can be able to maintain the code as well. So these are all some of the advantages of having object oriented programming structure. And also code reusability can be done. As we have already seen, the codes can be very easily reused again and again. So we know that in a base, we have a base class and a derived class. All the base class properties can be got to the derived class. That's our child class. So codes can also be reused again and again. Okay, let's see what is the major difference between procedural programming and object-oriented programming. So it's a somewhat it's a new term for some of the people. Let's see like what is meant by procedural programming in the sense we have to write it in an order. So that's what is procedure, right? So in C and all, what we will be doing, initialization has to be done at the first, and so all the methods has to be declared before. So all these types of things comes under procedural programming. And in object oriented programming, there is no proper structure has to be followed over with the help of object oriented programming. Just it should follow all the object oriented principles, and that's enough. Like we will be having class, objects, data abstraction, inheritance. So all these things has to be followed, and that is greatly enough whenever we were about to get any object oriented programming has to be done. Let's see, like procedural language is based upon functions, whereas object-oriented language is based upon real-world objects. So we will be creating objects. So objects has to be created with the help of new keyword, and we will be accessing this object from the function. So simply we will be using object-oriented real-world objects for object-oriented. And we have procedural language gives importance on the sequence of functional execution, whereas object-oriented language gives importance on the basis of its state and behavior of the objects. So with the help of state and behavior, we can be able to achieve object-oriented programming. And we have like procedural language exposes the data to the entire program. So take for example, throughout the program, it can be able to, like procedural languages can expose the data, whereas object-oriented programming will encapsulate the data. We have seen like object-oriented programming consisting of a term encapsulation, which is nothing but binding of data and its methods together is known as encapsulation. We have seen those things as well. Now, and we have procedural languages which follows top-down type of approach. So take for example, whenever the program starts at first, from the first it will be getting executed. So that's what is known as procedural language. Whereas object-oriented programming follows programming paradigm. So if a function has to be called, if a function call has been made in object-oriented programming, take for example, that function has to be called and then it will be getting executed. It's not top down or bottom up approach. It is based upon programming paradigm. So as far as the program, it is flexible. So that's how our object oriented programming language will be actually executing. Okay, let's take what is meant by procedural language. So procedural language is generally like complex in nature and it's very difficult to modify. So in our object oriented language and all, we can be able to declare some of the variables whenever necessary. Local variables can be declared anywhere, but in procedural languages, any changes or modifications has to be made, like initialization has to be made, in the sense it will be somewhat difficult and it is very complex in nature as well. So whenever we were talking about procedural language, so it is very complex. Whereas procedural language will be providing less scope of code reusability. So, take for example, we cannot reuse the code again and again in procedural type of languages. But in object oriented, we have seen that we can be able to make code reusability, right? With the help of inheritance, we can be able to achieve code reusability. So, very much pretty clear that we can be able to use object oriented language, which will be very much comfortable because it doesn't follow any type of top down bottom up type of approach, because it is using programming paradigm, and code reusability can be done, and initialization of variables has can be done anywhere. We must follow some sort of object oriented principles. That is enough, we can be able to create a program over here. But in functional programming and all, what we like procedural programming, we need to declare the variables at the first. So all these types of things has to be followed over here, but this is not necessary in object oriented programming. So this is one of the major advantage we have. Okay, we were talking about what are all the like concepts of object-oriented programming, right? So we have given clearly over here. So we have abstraction, encapsulation, polymorphism, inheritance, composition, association, and aggregation. So all of these things are generally object-oriented programmings. So, take for example, we will be having abstraction, so which is nothing but we will be hiding all the implementation details and showing only the functionalities abstraction. Encapsulation. So, let's see each and every other things in a very brief manner. Okay, let's see like what is meant by abstraction. So abstraction is like we will be hiding all the implementation details and showing only its functionality, is known as like abstraction. Take for example, I'm making an addition operation here. I'm also making all the implementations here and just giving abstract add. So abstract creating a function abstract void add. So likewise, I'm going to create only the functionality with the help of abstract keyword. So that is meant by abstraction. So abstraction is generally like hiding all the implementation details and showing the functionality. It is of two types, like we have abstract classes and interfaces. As we have already seen, abstract class through abstract classes only partial abstraction can be done, but in interfaces 100% we can be able to achieve abstraction. Let's read out the definition and go. Like abstraction is an object-oriented programming concepts to construct the structure of the real-world objects. During this construction, only the general states and behaviors are taken, and more specific states and behaviors are left aside for the implementers. This is generally known as abstraction. Okay, then let's talk about what is meant by encapsulation. So, as we have already seen, it is wrapping, like we will be binding up methods and its variables together into a single class is known as encapsulation. So, let's read it out. Like encapsulation in object-oriented programming concept is used to create and define the permissions and restrictions of an object and its member variables and its method. A very simple example is to explain the concept to make the member variables of a class private and providing public getter setters method. So this is how we will be generally creating an encapsulation. Okay, let's see how we can be able to, what are the different types of access modifiers. So generally we will be having public, protected, and no modifier and private. So these are all the different types of access modifiers. Even in Java 8, so they have created default method, so which is also an access modifier. So let's see about it that as well. So it is simply like we will be creating a concrete class inside an interface. So that's what we will be calling it as default keyword. So like we will one small thing with an interface, like we will be generally creating like 100% abstraction has to be done, and we cannot be able to initialize of concrete method inside the interface, so we can't able to do that. But with the help of default keyword na, so we can be able to directly declare like default void star, so we can be able to directly create it with the help of default keyword. Let's see like what is the major difference between abstraction and encapsulation. So with the help of abstraction, so we know that program, let's read it out and come to a conclusion, like program to interfaces, not implementation. That's what we will be calling it as abstraction. We know that abstraction can be achieved with the help of interfaces. That's what they were about to say. And what they were about to say for encapsulation is encapsulation that varies as known as like object oriented programming encapsulation. So binding up all the data and methods together is generally known as encapsulation. And abstraction provides a general structure of classes and leaves the details of implementers. So generally like abstraction, so it will be generally providing classes and its method, whereas encapsulation will be just used to define the permissions and restrictions of the objects and method variables and methods. So this is what we will be using. Abstraction is implemented in Java using interfaces, whereas abstract classes, while encapsulation is implemented in four level types of access modifiers like public, protected, no modifier, and private. So these are all the difference between abstraction and encapsulation. Okay, then let's talk about what is meant by polymorphism. So polymorphism is like we will be having currents or in various forms. So that is that we will be calling it as polymorphism. Polymorphism, the word itself says like we will be having different. It is take for example, the class name can be same, but the parameters can be different. So like some of these things are similar. That's what is polymorphism. So difference in some of the morphological characters is polymorphism. Let's take like Java supports various forms of polymorphism like polymorphic reference variable, polymorphic method, polymorphic return type, and polymorphic argument type. It generally means like argument types can be varied in compile time type of polymorphism. Return types can be varied in compile time type of polymorphism. The method names can be varied. Yeah, definitely. The method names can also be varied, and that's what we will be calling it as compile time type of polymorphism. Reference variables can also be varied. Yes. Like this comes under runtime polymorphism because methods can be declared in different types of classes because the same method can be repeated in different types of classes. So that's why we will be calling it as a runtime polymorphism. And we will be having reference variables can also be varied. So that is what are some of the types of polymorphism. Generally, we will be having two different types of polymorphism. One is like compile time, and we have runtime type of polymorphism. Let's talk about inheritance. So inheritance, we have seen like the subclass. Subclass is otherwise known as the child class, right? That can inherit the states and behaviors from its superclass. So it can be able to inherit the states and behaviors from its superclass or parent class is known as inheritance. Simple. So subclass can be able to inherit the states and behavior of its superclass is known as inheritance, right? Then let's see what is meant by multiple inheritance. So multiple inheritance is like we have seen we have two different parent classes which actually acquires the characteristics from its child class is known as multiple inheritance. The child class inheriting the states and behavior from multiple parent classes is known as multiple inheritance. Like multiple parent classes are there. That's why it is known as multiple inheritance. We can easily define it like class can derive the properties like states methods from multiple parent classes. We have class A and class B, so these can be derived multiple inheritance. Okay, let's see one of the important question like what is meant by diamond type of problem in inheritance. So imagine we will be having multiple inheritance. We know that what's meant by multiple inheritance. A child class which derives the properties from more than one parent classes is known as multiple inheritance, right? So in case of multiple inheritance, suppose we have class A have two subclasses B and C. Okay, let's write it clearly here. Class A has two different subclasses B and C, right? And class D that has two superclasses B and C. So class D have two superclasses B and C. So this is how diamond problems can be created. If a method present in A, we have a method. Oh, okay, let's take a method present in A is overridden by B and C. Okay, the same method can be overridden by B and C in this case, but not by D. Why? So why D cannot be able to inherit the same from which class D will inherit from the methods like B and C. This problem is known as diamond problem. So generally what they were about to see is we have a function A that can be inherited by its subclass A subclass B and C but not with D. So that is what we will be calling it as a diamond problem. We cannot be able to create a diamond type of structure, type of inheritance that cannot be possible with the help of diamond problem. So that's why we will be calling it as a diamond problem in inheritance. Okay. We have already discussed this in short, like what is meant by why Java doesn't support any multiple inheritance. So, like Java was designed to be a simple language and multiple inheritance now. So that introduces complexities. Like let's just define what is meant by multiple inheritance. We have two base classes and we have a one derived class which derives the properties from two different base classes. So that actually increases complexity. So that's what they were also about to say, like it increases complexity like diamond problem. So diamond problem might be arriving because of this complexity, right? Because this half now, so this is actually creating some multiple inheritance. So inheriting states and behavior from two different types of classes in case of reality is very rare, and it can be achieved easily with object association. So yeah, how we can be able to solve this multiple inheritance? We need the answer, right? Inheriting for that what we will be doing is with the help of object association we can be able to achieve multiple inheritance. Okay, let's take what is meant by static and dynamic binding. So static or early binding is like compile time binding is known as static binding. So like static binding is otherwise known as compile time binding, whereas so it can be resolved in compile time itself. Method overloading is an example of static binding because we know that it's a compile time type of polymorphism. We can say like static binding can be resolved like compile time type of polymorphism. Method overloading is an example of what static type of binding, whereas dynamic or late or virtual binding is resolved at runtime. Method overriding is an example of dynamic binding. That's it. Like it is similar to that of having compile time polymorphism and runtime polymorphism. So this is what we will be generally calling it as static and dynamic binding. Okay, let's see what is the meaning of having is a and has a relationship. So over here, take for example, we have is a relationship, right? Which implies inheritance. So take for example, I have a parent class which I'm about to call it as like car. Okay, so I'm calling like what we can say like Audi. Okay, so Audi is a child class. So take for example, here we were about to create an inheritance. So over here is a relationship will be implementing inheritance. The subclass object, this is the subclass, right? The subclass object is said to have is a relationship. Yes, so what will be like is a relationship? Audi is a car, right? So clear. So like this relationship can be achieved through inheritance. Like a subclass is said to have is a relationship with a superclass or interface. Okay, if class A extends B, then it is a relationship, right? So class A, right? What's meant by class A? This one, right? This is being extended by this is class A and this is class B. So class A can be extended by class B, then it is called is a relationship. Whereas, take for example, when a class A has member reference variable of type B is known as has a relationship. It is otherwise known as aggregation as well. So, like, take for example, I have A. Like A and B. So, A has some of the member reference. So, like, we are creating a reference that can be called in class B, then it is known as aggregation. Let's take what is the difference between association and aggregation. We know that association is like a relationship between two objects with multiplicity. So that's what is association. So it generally follows is a type of relationship. So association will be generally following it. Uh, what is meant by aggregation in the sense aggregation generally has a relationship. So what it will be doing is when class car has a member reference variable of type wheel. So take for example, I have a class car. Okay, I have a reference of a wheel. Okay, a wheel, right? So we will be having a wheel. So when a class car has a member reference variable of type wheel, and there is a relationship like car has a wheel, right? So it has a wheel. So that's what we will be calling it as like aggregation. Aggregation. Double G will be there. Let's speak like this. So aggregation, association is like they both are associated. They both are interconnected. They both has a relationship. Whereas aggregation, sorry, like they like we have car and then Audi. So like it has an is a relationship that will be present like association. Whereas aggregation is like aggregation is generally consisting of has a relationship like car and wheel. So like a car has a wheel, right? We will be able to connect with this. So that's what we will be calling it as like aggregation. So aggregation is a weak association. So what is meant by weak association in the sense car has a wheel, but like car has a whole and wheel is a part, right? So car will be like it's absolute, but within a car, right, wheel is a part, right? So it is a part of a car. So which actually means like it is a weak association. So aggregation is a weak association. That's it. A wheel can exist without a car, but a car cannot exist without a wheel, right? So that's why we will be calling it like a weak association. Okay, let's see what is meant by composition. Composition is a special form of aggregation. We know that what is meant by aggregation. We have a car and we have a wheel. So it's a composition is like special type of aggregation where a part cannot exist without the whole. Okay, so partner. So what is meant by a part? So part cannot exist without the whole thing. So it is not it is indivisible. So we cannot separate these two is known as composition. It is strong association. So aggregation is a weak association. Composition is a strong association because both are associated with each other, right? We can't able to separate both. That's why we will be calling like composition. Composition relationship is represented with aggregation with one difference is like it will be like a diamond problems it will be filled like a diamond shape. So it can be completed in a diamond shape. So that is what we will be calling it like composition. Let's see what is meant by dependency. So, take for example, when one class depends on the other because it uses some point of time, then it is known as dependency. Like one class depends upon the other is dependency. We know that, right? Okay, when one class depends upon the other independent class and the parameter is a parameter or local variable of the method of the dependent class. A dependency is drawn as a dotted line of dependent class to the independent class with an open arrowhead pointing to the independent class. So, how we can be able to create it? How we can be able to create a dependency? We have two different types of classes. So, we have to create a dotted arrow. Take for example, it is a strong class. Okay, it's a strong class. It's a weak class. So we are about to get this to be dependent upon this. So that's how dotted line should point to the arrow like this. So this is how we will be creating a dependency. Okay, let's talk about what is the difference between association and dependency. Um, okay. what is the difference? We know that association is a relationship, right? That's what is association. Or RD is a core. That's what we will be calling it as like association. What is meant by dependency then? Dependency is like one strong class is there, one partial class which is dependent on other. We will be calling it as like dependency. We will be creating a dotted arrow to demonstrate this dependency. And this is the type of dependency that we will be creating. Like a major difference between association and dependency is that in case of association of one class, attribute or member variables of other class type. In case of dependency, a method, other class or a method has local variable of other type. What is a class? Class is a specification or template of objects, so which has consisting of objects. So that's what we will be calling it as a class. What is meant by a class? So what is meant by an object then? Object is an instance of class. We have a class and we are about to create an instance of a class with the help of objects. So that's why we are calling it as like instance of class. Then let's see what is meant by constructor. So constructor is generally used to initialize the state of the object. So we have some rules for how we can be able to define a constructor. So take for example, the constructor name and the class name. So the class name and the method name should be same. Constructor should have no return type. So this also you should need to take into consideration. So it should be void or something. It should not have any return type. So that's what we will be generally calling it as a constructor. Let's see what is meant by destructor then. Destructor is a method which is automatically called when an object is made of scope or destroyed. So whenever an object is destroyed, about to get destroyed, we can be able to use destructor. Destructor we will be using like tilde symbol. So this is what they will be calling like tilde. So it will be present like with the help of tilde we can be able to demonstrate a destructor. Okay, what is meant by inline function then? Inline function is a technique which is used by compiler. Okay, whenever we were about to use a compiler, we will be using an inline function that is used to instruct to insert a complete body of the function whenever the function is used in a program source code. So generally, like we are creating a function. Okay, so that function has to be included in a whole program with the help of inline function. Okay. What is meant by operator overloading then? Operator overloading is a function where different operators like plus, minus, multiplication, division, so all these things are applied and depending upon the arguments. Operators, minus and multiplication can be used to pass through a function and this has its own precedence to be executed. So depending upon that it will be getting executed. So like it is also a part of overloading. We have seen like different types of parameters can be overloaded in a same method. So likewise operator overloading will be allowing these types of things as well. Okay. Then let's see what is meant by an abstract class. An abstract class is generally it cannot be instantiated. We know that, right? We cannot able to instantiate an abstract class. We have to create only an abstraction, and implementation has to be done in a separate class. We know that, right? So it cannot be instantiated. And then creation of an object is not possible in abstract class, but it can be inherited. So we can be able to inherit from one class to another. Inheritance can be done with the help of abstraction, but object creation has cannot be done over there. We will be using abstract keyword, right? So for creating abstract classes, Java only allows abstract methods in an abstract class, while for other languages it does not allow any abstract methods. Okay, let's see what is meant by interface then. Interface is like a collection of abstract methods is known as interface. So within, take for example, if a class that implements an inheritance, so thereby it inherits all the abstract methods of interfaces. So it will be generally creating all the abstract methods within the interfaces. Okay, generally we will be using implements keyword whenever we were about to create an interface. That is also very important. We will be using implements, class A implements B. So likewise, we will be creating what is meant by exception handling then. Exception is an event that occurs during the execution of the program. Take for example, I'm having a try block. Okay, whereas I'm about to try like integer a is equal to 10 by 0. So likewise, I'm just creating an exception. So I'm just creating an error. So that should be caught. Like we'll be using catch for handling this exception. That's what like execution of the program and its exception has to be handled with the help of exception handling, right? Okay, we will be having two different types like runtime exception and error exception. What we will be calling like runtime type of exception. So whenever the program is about to get executed, take for example, we have checked exception and unchecked exception. So checked exceptions are like arithmetic exceptions. Like array index out of bound exceptions are said to be checked exceptions, whereas in unchecked exceptions we will be having file not found exceptions. These things we will be calling like unchecked type of exception. So some of the things can be handled in compile time, and some types of exceptions can be handled in runtime as well. So these exceptions are handled properly through exception handling mechanisms like try, catch, throw. These keywords can be generally used to create exceptions. Like exceptions can be handled via this.